Hello students, today we are going to see this bubble sort algorithm. Okay, so last class uh, we have seen the topic which is known as search. Okay, so in a group of data you will be searching some data and finding the position of it. So in this class we are going to see this sorting means arranging. Okay, so arranging the group of data either in ascending order or descending order is known as sorting. So this there are three types of sorting techniques available in your syllabus. So one is bubble sort, and the next is selection sort, and the next is insertion sort. Okay, so these three topics are going to be discussed in today's class. So let's get into the class. So bubble sort algorithm is a simple sort algorithm. The sort starts at the beginning of the list of values stored in an array. So it compares each pair of adjacent element and swaps it if there is if there are in unsorted order. So this comparison and passing to be continued until no swaps are needed. So which indicates that the list of values sorted in an array is list of values stored in an array is sorted. So the algorithm is a comparison sort. It is named for the way of smallest element. Okay, bubble. So why do they name this algorithm as bubble sort? Means the smallest part in the water, the air is very smallest part. Okay, so smallest element. So air is formed in a bubble form. So what happens when bubble formed inside the water? So the bubble will automatically rise upwards. Okay, so rise upwards and it reaches to the top. Likewise, so here the smallest element will automatically come to the top of the list. Okay, top of the array or top of the list. Okay, so this is what it's done here. So the basic work is it will compare the first two elements. If the second element is lesser than the first element, then it will swap it. Swap means exchange the position of it. So we'll see that one by one. So this is the work that is done here. So we'll get into the pseudocode. Okay, pseudocode means the steps that are done here. Okay, so assume list is an array of an element. The swap function swaps the value of the given array element. Swapping means changing the position. Okay, interchanging the position. We'll see that. Okay, so start with the first element, that is index is equal to 0. So we'll take the example here: 15, 11, 16, 12, 14 and 13. So 15 is the first position. So here you can see that index is equal to 0. Compare the current element with the next element of the array. So first you can see that 15 and 11 is compared here. Okay, so 15 is greater and 11 is lesser. Okay, compared to these two values. Okay, so comparing the current value, which is 15, with the next value 11. If the current value is greater than the next value, swap them. Swap them means interchanging. So here you can see that in the next step 11 has become in the index of 0 and 15 has become index of 1. So in the starting position you can see that 15 is in the position of index 0 and 11 is in the position of index 1. Now you can see that 11 is become uh, is placed in the index 0 position and 15 is placed in the index 1 position. So all this element has some index position, which is the address of it. Say for example, this 15 is 0 index 0, 11 is index 1, 16 is index 2, 12 is index 3, uh, 14 is index 4, and 13 is index 5. So starting from 0 up to 5, so all the element have 6 elements are there in this array. Okay, so with like this they will be swapping it. Okay, so here you can see that in the next step, so comparing the 11 and 16, so already they are in the exact position. Okay, so 11 is less there and 16 is greater, so there is no need to swap it. Okay, so next is you can see that 16 to 12. Okay, so 12 is lesser and 16 is greater, so they are changing it. So and next you can see that 16 to 14, so 14 will come back to the previous position and 16 will go back to the next position. Now 16 to 13, that 13 will come again. So and then it will start again from the beginning. Okay, 11 to 15, 15 to 12, 14 to 15. So this will keep on moving until when this algorithm will stop means until there is no need of swapping. So it checks all the position, all the elements, so that there is no need of swap. Okay, so then only this sort will end. Okay, so at the end you can see that this is the sorted result. So next is selection sort. Okay, so here also the same kind of sorting is done, but in a different way. Okay, so consider this is the list of array. Okay, initial state of array 13, 16, 11, 18, 14 and 15. Okay, so it will fix one position. Okay, say for example first position. So this first position will have very less value. Okay, so the number which is very low. Okay, so it searches for the very lowest number. Okay, so the you can see that 11 is the very smallest number here. Okay, so it will swap immediately to the next first position. Okay, so in the next step you can see that 11 is swapped to the first position. So leaving the first position and taking all other element. Okay, so say for example 16, 13, 16, 13, 18, 14 and 15, it will compare all the element and find whether what is the next smallest element. So 13 is the next smallest element, it will swap to the second position of it. So likewise it will keep on changing it until all the elements are swapped together and to find the swapped list here. Okay, so this is the working principle of this selection sort. Okay, it will select a position and then it will find the least element of the list here and swap it to that selected position. Okay, so here you can see that 13 is the selected position, so first position. So 11 is 11 is the smallest element and smallest element is placed in the first position. Now it selects the second position and finds the least element, which 13 is the least element in the remaining place. So 13 is placed in the second position. Now here you can see that 14 third position is selected and finds the uh, place it in the third position. And in the next place you can see that 15 is the least position, it is kept in the 15th position. So likewise it will keep on changing the swapping the values until it reaches the sorted array. Next is insertion sort. Okay, so here you can see that while inserting itself it will swap the uh, swap the sort the array. Okay, so here you can see that 44 is the first element. So here you can see they are inserting 16. So 16 is less than 44. So it will create a position before 44 and place this number 16 before 44. Next you can see that inserting 83. So 83 is greater than 44, and you can see that it will create a place and next to the 44, which is 83. Now here you can see that they are inserting 0, 7. 7 is a value which is less than 16. So it creates a position there and place the value 7 before 16. So likewise it will keep on inserting text and also arrange them and place it in the required position of it. Okay, so this is a way of sorting in insertion sort. Okay, so here you can see that this is the pseudocode for insertion sort. If it is the first element, it is already sorted. Okay, it will assume that the first element is already sorted. Okay, next pick the next element. So compare with all the elements in the sorted list. Okay, so 44 is the only value here. So 16 is added, should be inserted in the array. So it will compare all the elements, which is only one. 44 is only element present in the array. So 16 is less than 44. So it is placing the value 16 uh, before 44. Okay, shift all the elements in the sorted sublist that is greater than the value to be sorted. So insert the value, repeat until list is sorted. Okay, so next is 83. So 83 should be inserted. It will compare all the values in the list. Okay, so 16 and 44. So 83 is greater than 16, so you cannot place it there. So 83 is greater than 44, so it must be placed next to 8 next to 44. So in the next step you can see that it is creating a space there and keeping the number 83 next to 44. Next is 07. So 07 is less than 16, so it keeps 07 before 16. So likewise it will keep on inserting until it it reaches the sorted array. Okay, sorted list or sorted array. Okay, so with this we'll finish the class. We'll see the rest of the things in the next class. Thank you, students.